to create a piecewise defined function for the graph and determine its domain and range. Okay, so how do we do that? So this piecewise is composed of 3 pieces. And you have two horizontal lines and a parabola. So it means that this equation represents a quadratic function. These are linear functions which are horizontal. So let's go in a clockwise direction so that it will be like in organized manner. So let's say you have this equation and you'd like to identify what it is. So as you can see in this graph, all the values of y are the same at -6. So therefore, the equation of this is y equals -6. It's also equal to f of x equals -6. So all horizontal lines have the equation y equals a number because the values of y in their graph will always be the same. Okay, if it's a vertical, all the values of x will be the same since it's going to intersect the x-axis. So with this line here, okay, your value of x here is -7. So therefore, your y is -7. Now, your f of x now will be equivalent to -7. Now, how is this possible again? So if you have the point here, so all values of y here will be -7. If I have this point, this is 7 and -7. If I have this point, this is 4 and -7. So all values of y, wherever they are, infinitely, all the values of y is -7. That's the reason why the equation is y equals -7. Alright, now let's go to the quadratic function. So this is a quadratic function and we can do that by means of algebraic strategy, but I'm going to make use of the calculator for this. So to form an equation using the calculator, you need to choose 3 points which will hit the graph. Do not choose those which are not exactly as it is, like a whole number for your coordinates. So let's say I'm going to try this point here. So this point here is -4 and +1. I will only choose 3 points, okay? And then I'm going to make use of these points even if they are actually in dots and they're not defined solution. But we can restrict the equation by means of this point. So this point here represents -5 and -4. While this point here represents 1 and -4. Okay, so we just have to put the values in the calculator. So our x values are, okay, -4, -5, and +1. And then our y values are 1. They should be in pair, -4 and -4. So let's try to find the equation by means of our calculator. So we will input this. So how do we go to this function of the calculator? You just have to go to stat and then edit, enter that, and then put all the values in the first column for x, -4, -5, and then +1. Okay? And then go to the y. You have 1, -4, and then -4. Okay? Enter that. After that, you need to go back to stat because you want to calculate it. So you go to calculate, and then since it is a quadratic function, you go to quadratic regression. Number 5, you can type number 5, or you can simply go down and use your cursor. So let's say 5. And if you want to store your equation in the calculator, you can do that by just pressing alpha trace. And then you can choose any y value you have here. Let's say I'll choose y1. So it means that the graph will appear in y1 when you press that function and then go to calculate. Alright, so that means the equation for this quadratic is f of x equals -x² because your a is -1. You don't need to write it. -4x plus 1. So that's the equation for our third function. So now we are ready to write our piecewise. So what is our piecewise for this? So write f of x first. You might as well write it here for a bigger space. So f of x equals. So our first function is, let's say in a clockwise direction, f of x is negative 6. Now, what is the restriction of negative 6? So you see the values of x here, okay, cannot extend to the right of negative 5. So therefore, our x is greater than or equal to negative 5. Since it includes 5, we have to put underline. Okay? Now we go to this equation and we know it is negative x squared minus 4x plus 1. Okay? And then after that, use the restriction. And as you can see, we have a hole here. It means that negative 5 and positive 1 are not part of the solution of this equation since they are not defined here. So therefore, your x is negative 5 is going to the right, so it means that your x here is greater than negative 5. And as you can see, I did not put an underline because it does not include negative 5. And 1 here is going to the left side, so therefore it should be less than 1. And again, there's no underline because 1 is not part of the solution of the problem. And then, of course, we have the third equation, which is negative 7. And in the equation, your x starts from 1 and it goes infinitely to the right side. So therefore, your x here is greater than or equal to 1. Okay? Then after that, you're asked also to find the domain and the range. So how do we find the domain? So the domain means the x values that will hit your graph. So from left to right. So you have to look at your graph left to right. Okay? So left to right, as you can see, all values of x are included. Okay? Even if there's a gap here, the gap here is in the y. Okay? It's not in the x because if I have here, I'll jump here. This is a combination of jump discontinuities. So you have here, I'll jump here, but the x values would still be included here. So it's from negative infinity to positive infinity. We can also write it as all real numbers. Okay? Or you can actually use this, but of course it will not show because you see, if I'm going to make use only of negative 5 and positive 1, and I'm going to make use of this, remember that the values of x between negative 5 and positive 1 are also included. So therefore, it is real numbers. So let's go now to the range. So the range is when you're reading your graph vertically and what includes these values. Okay, so let's start first with the bottom graph. So the bottom graph says that the values of y here is only negative 7. So therefore, the value of y is negative 7 and nothing else. Okay? And then after that, your y here, okay, it doesn't matter actually where you start, you finish, whether it's clockwise or counterclockwise. Now, let's say we do this first instead of that. Okay, your y here, okay, the values of y here do not include negative 4 because it's whole. Remember, you're reading it vertically. It's whole here. So negative 4 is not part of our solution for y. So unite, which means that negative 7 union, and 4 is not part, so we need to put parentheses because the parenthesis tells you it does not include it. So negative 4, comma, and it's from negative 4 to this point, and you see 1, 2, 3, 4, 5. So it's 5. So it's from negative 4 to positive 5. Okay, so that means I'll put 5 and there's not a hole in here. So I'm going to make use of bracket for positive 5. Okay, union. Okay, now we go to the third graph and the value of y here include only negative 6 and nothing else. So therefore, it will be in the union of negative 6. So it's a little tough to read the graph, but remember, when you're looking for the domain, you will have to find all the values of x that will hit your graph. So you have to read your graph horizontally. In this situation, from left to right, it goes to infinity here, it goes infinity here. You might be wondering, there might be a gap in between this, but there's none because it will continue in the graph here. Even if I have a hole here, which stands for negative 5 for x, it's not included here, but it is included here. This one, I have positive 1 here. It's not included in this area, but it is included here. So it's from negative infinity to positive infinity. In reading the range, okay? Now remember, there's a gap between negative 4 and positive 6. So this means that negative 4 is not part in those numbers before negative 6. And also, there's a gap between negative 6 and negative 7. So numbers in between negative 6 and negative 7 are not part. So we might as well take them into pieces. So this one includes only negative 7. This one includes only from negative 4. We're reading it vertically from negative 4 and positive 5, excluding negative 4. So we use parentheses for negative 4 and a bracket for 5 because that's not a whole. And our third graph says that the only value for y here is only negative 6. And that's how you read domain and range of a function in the piecewise.